Good day, students. Today in this video we're going to look at the solution to 4a, part of your long answer questions from chapter 2 sample quiz in book 1 of your ma1026 booklets. And in this particular question it's asking us to solve the system of equations by using any method, any algebraic method. So we see a system here. Now it seems to be the favorite one is called the multiplication addition method, or often referred to as elimination, and that's the method I'm going to use today, the multiplication addition method, or some people refer to it as elimination. Okay, now this method, the elimination method, multiplication addition, implies we multiply, we add to eliminate. Okay, and that's exactly what we're going to do. Now remember, we need the same coefficient but opposite signs in front of a number, so when they add the two equations together they'll cancel. Now I already got opposite signs right here and here, but not the same number, because if I add those now nothing cancels, so it's a waste of time to add them now. I'll get 8x plus y equals negative 22. Nothing canceled, right? So that's not what you want to do. You want to get something to cancel. So you choose a numbers and multiply equations by certain numbers so that when you do add them they cancel. Now I'm going to choose to cancel the y's. Now if there's a 4 down here, well, I'll multiply that by whatever number is here, so I'll multiply that by 3, and if I want to cancel the other one I multiply it by 4. So I just switch the numbers. The signs are already opposite, so this will give me, when I multiply that, it'll give me negative 12, see, y, and this will give me positive 12y, so when I add them they cancel. So that's what we're up to. Okay, so let's now go right through the full solution. Alright, so once you figure those two numbers, write them in front of the equations, and I tend to put a circle around them to highlight them. So I'm going to multiply the top equation by 4 and the bottom equation by 3. Now distributive property rules require me to multiply by every term. Okay, do not forget to multiply by every term. So the top equation will transform to 4 times 5, which is 20x, 4 times negative 3, which is minus 12y, and then 4 times negative 21, which is negative 84. Okay, the bottom equation, multiply that by 3, and that becomes 3 3s are 9x, 3 times 4 is positive 12y, and 3 times negative 1 is negative 3. Now watch what happens when you add. Here comes the elimination part. Boom, gone. 20 plus 9 is 29x equals, add two negatives, still a negative, that's 87. Of course you know what to do now. Divide each side by the coefficient of the x term to solve for x, and that turns out to be x equals negative 3. Now you're not finished. Remember, a solution to a system is a set of ordered pairs, so you still have to do one other thing. Now most people will not go back and eliminate, they'll just sub this back into either of those equations. Doesn't matter. So pick an equation, sub it back in. So I'll pick the bottom one, 3x plus 4y equals negative 1. What is x now? X goes in here, so 3 times negative 3 plus 4y equals negative 1. We got negative 9 plus 4y equals negative 1. Bring that 9, right, add 9 to both sides, gives us negative 1 plus 9, and 4y there equals positive 8. Divide each side then by the coefficient of y, which is 4, and we get y equals 2. So it looks like my solution, I'll move that over there. I'm going to move this over just because I want room to check. Okay, so I'm saying then, therefore, my solution to a system, by the way, is always an ordered pair. So I'm saying the solution to this equation, to this system, is negative 3, positive 2. Okay, now you can verify that by substituting into each one. So if I do a check here, I'll take that and I'll substitute it into the top equation. Okay, now are these equal? So 5 times negative 3 minus 3 times 2, does that equal negative 21? Negative 15 minus 6, look at that. They are indeed equal. Okay, and you check the other equation. I don't have a lot of room to check the other equation, so I'll move up right here. 3x plus 4y equals negative 1. Is this going to be equal? 3 times negative 3 plus 4 times y, which is 2. Does that equal negative 1? And I get negative 9 plus 8, right, equals negative 1. Look at that. Negative 1 equals negative 1. So both checks work. We're 100% certain that negative 3 comma 2 is our solution.